Good morning, good afternoon, good evening, kids. This is your nice sir. How are you doing? This video is for grade 8, rational number, CBSE. What are we going to learn in this lesson? We are going to have a quick recap on the types of number. That is your whole number, natural number, integer, all that. We are going to study about properties of rational number. The properties are the closure property, commutative property, associative property, distributive property, identity property, inverse property. All this is what we're going to study. We are going to study addition and multiplication of rational number. Mathematics is all about addition, subtraction, multiplication, division. So with rational number, how are we going to do? We are going to study the additive, identity, and inverse, multiplicative identity and inverse. I'm going to give you a trick on this for your identity. Watch on this video till the last to know more about it. Rational number on a number line. Yes, every single number can be represented on a number line. So how are we going to represent a rational number on a number line? Again, there is a trick. I'm going to teach on that. Rational number, what a great, what a smaller. Again, all my teaching would be to make it very simple for you with some tricks that I have learned in due course of time. And then afterwards, numbers between rational number between two numbers. How many rational numbers are there between two numbers? That's a question which is being asked. There is a lot of question which comes across, is 0 a rational number? Okay, so all this thing we will be clarifying and we will be having an insight in this video class. So let's look into it. The first thing, natural number. These are all on the recap. Most of you know, and I think everyone knows what is a natural number. Natural number starts from 1 and goes up, infinite. Now, what is a whole number? A number, when it is added, when a natural number is added with 0, then it is called as a whole number. That is a great mathematician, Aryabhatta, who gave us 0. 0 came from India. So be proud of it. So that is whole number, which is 0 plus all the natural number. Integers, all positive and negative numbers together, including 0. Because whenever I have seen across asking kids that is 0 an integer, they get confused. 0 is an integer. Rational number. If I write a number in a form of p by q, where p and q are integer and q is not equal to 0, why is it that every time you are listening to saying that q is not equal to 0? Let me give you an example. Let's take that I have got a number 2. I know that this is a natural number. This also comes as a whole number. This also comes as integer. And this is also a rational number. And that is the reason why a lot of kids get confused. That means if I want to draw like this and say this as my natural number, I put one more this whole becomes whole number. And if I put one more circle, it becomes integer. And this whole becomes rational number. So every natural number is a rational number. Every whole number is a rational number. Every integer is a rational number. But sir, we were talking about P upon Q. But this is 2. Can I write 2 as 2 upon 1? Am I right? That's where it is considered. That is the only reason why this is a rational number. Don't get confused. It's very simple. That means any number which is a natural number is a whole number. Any number which is a whole number is an integer. Any number which is an integer is a rational number. Number system. Okay. Now coming to this, that why am I saying that P upon Q where Q is not equal to 0? Why am I saying this? And okay, there's one more thing which a lot of kids comes up to me and say, they said, what is this P, Q and all that? I don't know. If suppose, let's say that in your class there are 30 students, and if the teacher tells everyone to guess a number, probably you would have guessed 100,000. Someone would have guessed 1 million, no? Someone would have guessed 10 billion, all a number. So when mathematically it is written in an alphabet form, P upon Q. Like for example, do you remember there was some questions that you used to say that your brother is 3 years elder to you. So you say that, well, let my age be X and my brother's age would be X plus 3. That is the only thing where alphabets are being used. P and Q, I don't know which number you are going to think. But there is only one condition, that Q should not be equal to 0. Now take an example. Let's say that I'm taking 2 upon 1. What is the answer for this? 2. 2 upon 0.1. What do I get the answer? 20. If I say 2 upon 0.001, this will become, look at the way the number is growing. And kids, this video is going to be a bit longer video because I'm going to teach the entire concept in it. But I promise you that if you see it 2 times, rational number will be registered in your mind. You will be able to solve all kinds of questions that are there in your NCERT book, in R.D. Sharma, everything. That is guaranteed. Are you with me? Let's continue. Now, if I put this number, sir, your writing is 0. I'm writing this. Is this 0? No, it is not 0. It is coming closer and closer to 0. Now look at this. What will be the answer for this? How many zeros are there? 2. 1, 2, 3, 4, 5, 6, 7, 8. And what is this? Indian system. You have studied that when you were in grade 6th. This is nothing else but 100, 1000, lakh, crore. 20 crore. That means as and as this number comes closer and closer to 0, the number is becoming very big. And that is the reason 2 upon 0 is not defined. And they give it as infinite. Hope I am very clear. Can I go further? Yeah. Question. Is 0 a rational number? Yes, 0 is a rational number. You remember getting, if ever you got 0 out of 10? 0 out of 20, 0 out of 100, and this is forming a p by q, where 0 is an integer and 10 is an integer. Therefore, 0 is a rational number. Okay. Probably what you can do is you can pause the screen and take a screenshot or write it in your notebook. I really recommend you to write it in your notebook. The one which I just showed you on the figure. All natural numbers are whole number. All whole numbers are integer. All integers are rational number. We are going to the next slide. Properties of a rational number. The moment when I speak about property, what do you mean by property? What is this word mean? Rational number and the property. 1 minute. I think my screen went before. When I talk about property, do you remember there is something called as salt at your home? There is sugar. When mom is making, let's say she is making a hot cup of tea or a chocolate milk for you, what is she going to add? Will she add sugar or will she add salt? Sir, what a question it is. My mom will only add sugar. But why? Because sugar has got a property. This has got a property. Sugar has got a property of what? Of sweetness. But the same thing is in case if mom is making your best of your biryani or your dal or whatever it is, she is going to use salt. That is a property. Similarly, mathematics, numbers have got a property. What are the properties? And this is one of the things which I have seen most of the kids finds it's difficult to understand. It's a very simple thing. I'm moving to the property now. I have got the properties of rational number. I'm talking of a closure property. I'm talking of commutative property. I'm talking of associative property. I'm going to talk about distributive property. I'm going to talk about identity property. I'm going to talk about inverse property. When I say closure property, if I add two rational number, what will I get? Will I get a rational number? If I get a rational number, that means closure property holds right when I add a rational number. Example. Suppose if I have got a rational number 1 upon 2 plus 1 upon 3, I'm going to get this answer as 6, 5 by 6. And what is 5 by 6? 5 by 6 is a rational number. If I do this minus 1 upon 3, what do I get? I get 1 upon 6. Again, it is a rational number. So that means closure property holds true for rational number. Okay, moving further, commutative property. Oh, wow. Okay, you are studying mathematics with a subject base language as English. And this is again one more thing which I have seen in a lot of kids, that the moment they are studying mathematics, they will take the specs of mathematics and put the specs of mathematics. No need. It's English. Because if you were studying in Japan and if Japanese was your base language, The word closure would not have been there. It would be something else, ching pang pung. Or in China, it may be ping pong pung. Oh, whatever it is, it's a word. It's a base language is English. So that's very important. If I can help you in decoding your mathematics with the baseline as English, mark my word, I guarantee that you will get more than 20%, whatever you are getting. The second part comes up is commutative. Commute. A plus B is equal to B plus A. Example, let's take 1 upon 2 plus 1 upon 3 is equal to 1 upon 3 plus 1 upon 2. When I do this cross multiplication. And what do I get? So the commutative property for addition is true. Now let me try for subtraction. A minus B is equal to B minus A. 1 upon 2 minus 1 upon 3 is equal to 1 upon 3 minus 1 upon 2. Again the same thing, 6, 3 minus 2. Again the same thing, 6, 2 minus 3. There I get 1 upon 6 and over here I get minus 1 upon 6. Are they equal? No. That means commutative property for subtraction fails. It is not true. Are you getting the whole idea? I'm going to take a bit more time on this particular part because if you know this properties, this closure, commutative, associative, distributive, identity, inverse, all these are going to be there till you're going to study mathematics. For sure till 12th. And most of the students find this properties understanding difficulty, nothing else. And when I talk about commutative, I'm talking of commuting from one place to other place. Now let me talk of associative. Associative property is and do you remember something called as this is equal to A plus B plus C. When you were studying in grade 5, 6, you have studied something called as mod mass. If there are 2 or 3 or 4 number, whatever number it can be a whole number, it can be a natural number, it can be integer, it can be a rational number, whatever it is, you have to follow the BODMAS rule. And this BODMAS rule, what are you going to do? You're going to solve the first bracket and then the second step. And this is what you're going to study. Going next, distributive property. Okay, distributive property has got a very unique thing. In mathematics, we have got addition, subtraction, multiplication, and division. If I use two operator, I'm talking about distributing. That means A multiplied by B plus C is written as AB plus AC. If they are equal, then and then only it holds distributive property is true. Let's take an example. 1 upon 2 multiplied by 1 upon 3. The reason of taking small number is to clear the concept, kids. Okay. 2 upon 3. All right. Now that will make it 1 upon 2 into 3 upon 3. And that is nothing else but 1 upon 3 into 2 upon 3. And that is nothing else but 3 upon 6. And whenever I get a rational number, I need to get it in the smallest form. So this will be 1 upon 2. So my LHS is 1 upon 2. Now let me look at for the RHS. 1 upon 2 into 1 upon 3 plus 1 upon 2 into 2 upon 3. What do I get? 1 into 1 upon 2 into 3. There are some steps which you can skip, but skip only if you are 100% sure. 1 upon 6 plus 2 upon 6, and that is nothing else 1 plus 2, and that is nothing else 3 upon 6, which is equal to 1 upon 2. So my RHS is 1 upon 2, my LHS is 1 upon 2. That means, what does that mean? The district property is true. And the same thing what you can do is, you can probably write this with minus also. So when you do this, this will also become minus. And you can check. Is it holding true or not true? Going further, identity property. Identity. You have got an identity. I'm talking about a number now. I have got a number. Identity of this number is 4. What is it that I can add to this number so that the number doesn't change? Can I add 1? But when I add 1, this becomes 5. It has changed the identity. So the identity means 4 plus 0 is equal to 4. This is identity property for addition. Am I clear? Going further, multiplicative identity. 4, sir, you told me 0 is identity property. 4 into 0 is what? Is it 4 or 0? It's 0. It has lost its identity. What is it that I can multiply it with? If I multiply it with 1, I get 4. If I multiply it with 2, I get 8. Lost. Identity lost. Identity lost. Identity is only maintained in this. So 1, multiplicative identity is this. Now the last part is inverse. When I'm talking about inverse property in addition, what do I mean? If I've got this number, by what number can I do something where this will become 0? Sir, minus 4. So minus 4 is the additive inverse of this number. Additive inverse. Look at the words. And if you really want to learn this, what I will suggest is, write this into your notebook, read it 5 times for 2 days, and you will remember it. You will it will be registered in your mind. Okay, this is what is the image for closure, for commutative, for associative, for distributive. On the last, on multiplication and this thing, they said it is not applicable. Tell me what property. Now we have got a question. Tell what property allows you to compute. There's some numbers given. You know, whenever you are getting a question, first and the foremost thing is what you need to do is understand that you need to decode the question. If I can decode a question, I will get the solution. But this is the pattern which I teach all my kids, that never jump to a question. First of all, just read the question, try and decode the question, and then automatically, once you are decoding the question, then the solution will come. Okay, so now let's decode this. I have got this, so let me just write A instead of this into B into C, and here it is A into B into C. Am I right? What is this? Think it is associative property. Associative property of multiplication. If it would have been A, if it would have been A plus B plus C and A plus B plus C, this would have been associative property of addition. Now let us just see the solution. Now it becomes very easy. Clear? Let's go next. I've got this number. Now look at this. Let me just write this. Again, I'm going to take a pause. And I'm just going to write A into B plus A into D. Sir, why have I written B and D? Look at this. B is, I'm taking as minus 3 upon 4. And this is a different number. So I'm giving a different alphabet. That's all. Can I write this as A bracket B plus D? What is this? Distributive property. And I can solve this as 1 upon 5 minus 3 upon 4 plus 2 upon 3. And this will become 1 upon 5 minus 3 upon 4 plus 2 upon 3. And this I can solve it further like 1 upon 5 underline 4 3s are 12, cross multiply minus 3 into 3 plus 2 into 4. 1 upon 5 minus 9 plus 8 upon 12. And that gives me 1 upon 5 minus 1 upon 12. And I multiply this further. 1 upon 5 multiplied by minus 1 upon 12. 1 into minus 1 upon 5 into equal, and that is nothing else but minus 1 upon 16. Going further, addition and multiplication of rational number. And you have studied this in grade 6, grade 7. You know what have you studied that way? You have heard a word called as fraction. Fraction is nothing but a rational number. Is it interesting now? Now it is very simple. When I say about a fraction, I have got 1 upon 2, 2 upon 2, 3 upon 2, 5 upon 3. A quick recap, okay, it's very important. This is a proper fraction. This is a proper fraction. This is an improper fraction. This is an improper fraction. And there is one more thing, if you notice, if I want you to add this only, 1 upon 2 plus 2 upon 3. Sir, the LCM, the denominator of this number are different. What do? I find LCM. But the same thing, instead of this, if I would have given, yeah, let's say, I take a 3 upon 2. Sir, the denominators are same. 1 plus 3. That is 4 upon 2. And that is nothing else but 2. Rational number is that much easier. You have studied it. This is only that you are studying that a fraction. Fraction is not a number. We are not saying fraction number. We say natural number, whole number, integer, rational number. And when you will be going to grade 9, you are going to study something called as irrational number. That will come later. When you go to grade 9, you will learn that. Now the same thing, if suppose instead of addition, if I say multiplication. What is the rule for fraction multiplication? 1 upon 2 multiplied by 2 upon 3, nothing else, numerator to numerator, denominator to denominator, and the answer is 2 by 6. If I get a number where I can make it small, the lowest form, 1 upon 2. Go further. Okay. If I change this to division, then what happens? When I go for division, what do? 1 upon 2 multiply by reciprocal of 2 by 3. What is the reciprocal of 2 by 3? And then, and that is nothing else but that's all. Your major part of rational number would be done. But you are in grade 8. So they are not going to make it very simple. They are not going to just tell you that, add 1 upon 2 plus 1 upon 3. They are going to test you with the properties. And when we'll be doing further questions on the slide, you will understand it. Okay? Let's continue. Oh. Addition. I have got 4 rational numbers. They have given me 4 rational numbers and they have asked me to add. That's the reason I told you. You are in now grade 8. they will be testing, they will be keeping a bar slightly more bigger so that you can jump. If the same question is given to a 10th standard boy, he will say it's very simple. But for an 8th standard child, he has to learn it. So this is a concept learning, and the video will be longer. Have patience and learn it. Okay. Now, if I look at this particular question, whenever I have got addition as a rational number and there are multiple numbers which are given, I am going to focus my eye only on the denominator. Now look at this. This is 7 and this is 21. There is something called as regrouping the number. And look at this number. This is 11 and this is 22. They are multiples. So what I do, I am just going to regroup them. One minute. I need to solve it. Okay, let's solve it. 3 upon 7 plus bracket minus 8 upon 21 plus bracket minus 6 upon 11 plus 5 upon 22. LCM is 21. 3 into 3 plus minus 8 into 1 plus 22 is the LCM, minus 6 into 2 plus 5 into 1. Okay, let me solve this. Okay, that's not quite good for correction. Okay, 21, 9 plus minus 8 plus minus 12 plus 5 upon 22. 9 plus minus 8 upon 21 plus minus 12 plus 5 is minus 7 upon 22. That will give me 1 upon 21 minus 7 upon 22. Now here both of them don't have any common. So what I'm going to do, I'm just going to do a cross multiplication. So this will become 21 multiplied by 22 and this will become 1 multiplied by 22 minus 7 multiplied by 21. And this will give me 22 minus 7 ones are 7, 7 2s are 14 upon 22 10s are 220, 22 20s are 440, 440 plus 22, 462. Okay, probably you can learn this way. 22 and 21. Can I write this as 22, 20 plus 1? And this will become 440 plus 22. And this will give me 462. Quick one for you. And the answer would be minus 125 upon 460. Okay. You can take a pause and you can write this from here. Going next. multiplication. I have got, as I told you, I have got 4 rational numbers and they're talking of multiplication. The moment when they talk about multiplication for me, I am going to look at numerator to denominator and I'm going to regroup them on that basis. Okay, let's see if I have got, yeah. How do I do that? Okay, I think I need to solve it. Minus 4 upon 5. Let me see. 5. Oh, there is 15. I'm going to bring this gentleman here. Multiply by 3 upon 7. Multiply by minus 14 upon 9. 4 ones are 4. 4 fours are 16. 5 ones are 5. 5 threes are 15. 3 ones are 3. 3 threes are 9. 7 ones are 7. 7 minus. Let me rewrite everything down. Minus 1 upon 1 multiplied by 3 upon 4 multiplied by 1 upon 1 multiplied by minus 2 upon 3. Numerator to numerator, denominator to denominator. Bit step, but very important. Okay, 3 twos are 6 and there are 2 negative. So this will become plus 6 upon 4 threes are 12. 6 upon 12. Smallest form, 6 ones are 6, 6 twos are 12. Answer is 1 upon. Okay, that's what 8th standard mathematics is all about. Yes, you can take a pause, do it by yourself, and then see if you're right or wrong. Going next. Properties. What are the properties that you'll learn? Closure, commutative, associative, distributive, identity, and inverse. 6 properties you have learned. Now, if you look at this question has got, okay, let me write A into B plus C minus A, sorry, B by 5, B into D. Sir, I've got the answer now. I have decoded. I have given respective values. Now simple. I know now what I'm seeing is I'm seeing this. And now my mathematics will become easier. I'm going to write this as A into B minus B into D plus C. I'm going to take B common. It will be A minus D plus C. Can you solve it? Just substitute the value. What is B I have taken? 3 upon 5. Bracket close. What is A minus 2 upon 3? What is D? D is 1 upon 6. Plus, and you can solve this. I'm not doing this, you can do it. But if you want the answer, here's the answer. Going further, answer is simple question. I want you to do it by yourself. Again, look at this one small, every time whenever you get a mathematics thing, this is A. Is there any A here? No. This is B. So this is A. This is B. I have got a B here. Okay. This is something else. So I'm going to get the C, and this is something else. So I'm going to pick that B. Equal. Okay. Pause it. Do it by yourself. Then only you will learn. Do let me know how do you find these classes. If you like it, share it with your friends. Let them also learn. Let them also score with you. Okay, sharing is caring. So share as much as you can. Additive identity and inverse. I have spoken about this part in my previous. Not going to spend. What number can I add to a number where the number doesn't change? It is 0. So 0 is called additive identity addition. Additive addition. Additive addition. Additive addition. Identity means I'm not changing the number. Multiplication. Oh, additive inverse. What number can I add to a number where it becomes 0? Write the additive inverse. Minus 7 upon 19. It is minus 7 upon 19. What is minus of this? Simple. With me? Good. And how do I check? I take the number and whatever additive inverse I have got, I will add them and see if the LHS is equal to RHS. Going further, you can solve this. I think without solving it, you can get the answer. Minus 2 by 8. Verify. I will leave this for you kids to do it by yourself. Multiplicative. Do you recollect what we learned in multiplicative? What number will I multiply with a number where the number will remain the same? Suppose if you're thinking 10,000 as a number, so what number will I multiply to 10,000 so that it will remain 10,000? It's 1. So 1 is called the multiplicative identity. What is multiplicative inverse? Yes. What number will I do so that I will get 1? 1 is the multiplicative identity. I need to get 1. So suppose I have got a number called as 2, I want to multiply a number in such a way that I will get 1. Do you remember transpose? So this number, and do you know what is this? This is called as reciprocal. Now same, If suppose if I am asking you for 7 upon 8, what is the multiplicative inverse of 7 upon 8? What is the reciprocal of 7 upon 8? The reciprocal of 7 upon 8 is 8 upon 7. And let me clarify, let me recheck. What do I get? 1. Because 1 is a multiplicative identity. 1 is called the multiplicative identity. And 0 is called the additive identity. Going further, all this I think you can do. I will not make it long. Name the property under multiplication used in each of the following. Name the property used in this. Multiply this by the reciprocal of this. Find the multiplicative inverse of the following. Check number multiplied by multiplicative inverse is equal to 1. Is 8 by 9 the multiplicative inverse of minus 1 whole 1 upon 8? Interesting question. 8 upon 9. The multiplicative inverse of minus 1 upon 8. Is 8 upon 9 the multiplicative? Now let me just write this number 1 upon minus 1 upon 8 is the mixed fraction. How do I make it proper fraction? Minus 8 plus 1. Okay, so what do I get? Now further from here you can do it. Okay. Minus 1 is not the multiplicative identity. 1 is the multiplicative identity. I was discussing about this question. Is 8 upon 9 the multiplicative inverse of minus 1 upon 8? What is that? I will, okay, answer is right on your screen, so probably you can just go through with it. I'll give you an understanding. Minus 1 upon 8. I'm going to write this as 1 into 8 plus 1 upon 8. I will get 9 upon 8. Now, what do I know? I know number multiplied by the inverse has to be 1. Now, what is the number that I've got? 8 upon 9 into what is the inverse? It is saying cut, 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 cut. 1 upon 1 into minus 1 upon 1. And that is nothing else but 1 upon minus 1 upon 1 into 1. That is nothing else but minus 1 upon 1. And that is nothing else equal to minus 1. Identity in multiplicative. Multiplicative identity is what? 1, not minus 1. Therefore, this is not the multiplicative identity. So 8 upon 9, your answer has to be there. You are in studying in grade 8. You cannot just leave it at equal to not equal to 1. You have to explain. Hence, 8 upon 9 is not the multiplicative inverse of minus 1 upon 8, as the product is not 1. You have to write this complete answer. I have seen lot of students just finishing at minus 1 and then writing it's not. No, you have to describe it. Okay, check on this. Is 0.3 the multiplicative inverse of 3 whole 1 upon 3? Why or why not? Do it. The rational number that does not have a reciprocal. Which number does not have a rational does not have a reciprocal? Can you tell me? Take any number. Take number 2. 2 can be written as 2 upon 1. 2 reciprocal is 1 upon 2. Let's take 1. 1 upon 1. It can be written as 1 upon 1. Only thing is, this has come over here and this has come over here. 0 upon 1. 1 upon 0. But 1 upon 0 is not defined. So, 0 is the rational number that does not have a reciprocal. Clear? Yes. Next.